Hey, welcome to Repair University Live. We are so thankful that you have joined us today for the training, and we are inside because it's hot in Arkansas.
It is hot out there.
Summer came early here, and so we've decided to move it in just so that we're not sweating through the whole show and wiping everything off. But man, have we got a lot to cover.
And we're taking donations.
We are taking donations.
For air conditioning.
For an air conditioning show.
Yeah.
Send it to larry.montanez3@gmail, and the appropriate people receive the money.
Yeah, yeah. I do love the fact that apparently I'm owned by all these people and I can't even afford air conditioning. So whoever apparently supposedly owns the company, I would really like you to call them to tell them to get us air conditioning.
Why, the 800-pound gorilla in the room doesn't own you?
I know, right?
Right.
So I just have an insurance company tattoo, but they don't own my, well, we'll cover that later.
Yeah.
All right.
That's a different show.
So yeah, so I'm really excited about this show because honestly, I don't really know much about it, right? It's not something we saw a lot here in my states and the territory I covered.
You still have horse-drawn carriages.
We still have horse-drawn carriages, right? And we didn't, so to us, this was all the exotics.
On the way in from the
Europeans.
airport, I saw a paved road.
Well, those are new.
I know.
Those are new.
Right?
Yeah.
I actually
So-
saw a waitress last night with like almost all her teeth in her head.
Almost all of them?
Almost all of them.
Really?
Yeah. Yeehaw.
Boy, we got so much going on. That's why people who love to come and vacation at Collision Hub, and we've got, 20-something people ranging from Washington to Hawaii to New York to flying in this afternoon for a live class we'll be doing tomorrow.
Yes.
So they are going to get to vacation in the natural state, which means naturally hot right now. So, all right, well, let's talk about mechanical fasteners because, like I said, this is a show that I've been looking forward to because I'm hoping to learn a lot more. When shops call me and ask a whole lot of questions, I go call Larry.
Yep.
All right, so let's talk about the history. What's the history of mechanical fastening and collision repair, right? Mike,
You're
welcome.
the expert.
We brought Reliable. We got you in here because this is your baby.
This is your world.
So let's start with the history here.
Mechanical fasteners, rivets have been used for quite a long time in the aerospace industry and space industry. And cars years ago, you really didn't use rivets in the car because you wasn't really called for. But now with the new technologies, the new steels, the new composites, construction of the vehicles, mechanical fastener is a very easily reproduced piece of fastening that can be consistently done by anybody. So you're not thinking of your welding skills or are you doing this correctly? It's a very easily reproducible piece of fastener.
I hear often where I talk to technicians, they're like, oh man, a rivet, that's not as strong as a weld. Well, I mean, I fly on airplanes a lot, and they're all riveted. They've always been riveted. Panels don't fall off airplanes. And then on top of that, the skill set, Larry and I were talking about this yesterday, that, if Larry were to teach you how to weld, and he's tried.
He's tried.
But, you could spend weeks perfecting how to weld, and then
you got further with that wall than you got with me on welding training.
You can spend weeks trying to perfect how to weld, but you don't necessarily. You shouldn't be welding a car.
No, at all.
But I could spend, and Mike could spend 2 or 3 hours with you. You do a little bit of practicing with this.
Yeah.
You could be riveting a car together tomorrow. So we can actually have a much more predictable repair.
Right.
That's just as strong, if
very
not stronger.
consistent results.
Yeah.
Consistent results with this technology.
Well, it's kind of like when you watch the welding test, right? You'll have some technicians come in, and the welding instructor spends about 3 or 4 hours getting them to just pass the Coupon test, right? And then you're thinking, holy jeez, that guy's going to weld on a car tomorrow.
Yeah.
So,
Well, once again, it goes back to like our welding class we did, and you need 3 to 4 hours a week on MAG, 3 to 4 hours on silicone bronze welding, and probably 6 to 8 hours a week, every single week practicing for aluminum, to get decent at it. To become great, you're asking maybe 40 hours a week for probably 6 months to become really great at it. With this, you can lower that down. Probably within a week, you could master riveting.
Yeah.
Now, you could take a B-Tech, let's say, that's working with an A-Tech. The A-Tech would secure maybe 3 or 4 of these rivets in the right spots, and then have magic marker wherever the rest of the rivets have to go. And I give the tech the right jaw clamp and this is even easier than a resistance welder because you just squeeze the trigger and the pressure's already set. There's no ambiguity to it. And I can have a B-Tech work alongside of me and actually put in the other 200 rivets on this panel after I put maybe 15, 20 of them. And that would increase the efficiency within the shop but also teaching a guy a different skill set, because this is easier to learn. You know, setting the panel up on the, cutting the panel, measuring the panel, getting the panel to line up is the same if you're going to weld it, glue it, or rivet bond it. But the ultimate overall process is that you need a higher trained tech to be able to weld in many cases. With the advent of these resistance welders that are automatic, this is kind of like where a lot of this is going. And like Mike said, it's due to the construction of the vehicles, all this aluminum that we're using nowadays, and the lightening up of the vehicle. They're trying to make repairs a little bit more efficient
and repeatable. So if there's ever a time when you hear people and technicians across social media that say, I've been doing this for 30 years, well, the car's not the same as it was 30 years ago. And so those very distinct changes that are safety initiatives and gas initiatives and all these things in cars have made us have to change the way that we attach panels. Point blank, I've got to have a repeatable, securable process, and I've got to take the human error somewhat out of it. And we can't get technicians to do welder setup or test on a piece of the panel they've taken off. We can't get them to do that, so let's give them something.
And we're going to talk a little bit more about this, but we're going to, in some cases, fix. They're going to weld the car together at the factory. And we're not going to weld it back together. We're going to rivet it. BMW, great example of that. We're going to talk a lot more about the self-piercing rivets, but it's a much more repeatable and strong repairer.
Yeah, and
we can use a slower skill set of somebody trained, it's trained to do it, but a lower skill set. I don't think that you put 4 or 5 welds into a quarter panel, then pass it off to your B-Tech and say put the next 100 in. Welding, not a good idea.
And I'll be honest with you, I'd rather carry around something like the Express 800 or any other rivet gun that's out there than to use a resistance welder all day long, just because of the size of the head, regardless of what contraption you have to help counterweight it. But I mean, this is very lightweight compared to the heavy head of and it's a lot easier to swing around.
And one of the other major components too, don't forget the new ultra high strength steels. You don't want to have heat in them anymore.
No.
So this is a cold process where you're not introducing any kind of heat.
We're going to talk a little more about that later too.
So the changes in vehicle design have made mechanical fastening come to the forefront. So it's not just that this isn't brand new technology. We've always had technology mechanical fastening available, but now
it's what I said to you back in 2010. The German influence is going to make it to modern, economical, mass-produced vehicles, as we saw in the Chevy Cruze program we did that time. Where they're using rivets, and they're using silicone bronze, and they're using resistance welds, and they're using silicone bronze welds in sectioning joints, just like a Mercedes-Benz. So we're seeing this more and more, and this German style of stuff is going to become more prevalent in other vehicles.
So let's kind of get into the meat and potatoes of what everybody's here. Now, don't forget, we do have a new way of taking questions that we unveiled on the last show, so you no longer have to type into us. You can use the text your questions straight in here to us. So we thought that would be helpful for maybe the people that are watching in a group of people. So let's talk about the different combinations. Larry, you're going to text yourself in on question. Larry Montanez is awesome. Please have him do more. All right, so walk me through the combinations of mechanical fastening and collision repair.
Well, it depends on, first of all, we're going to go right back to, we're going to start off any repair on any car. We're going to start at iCar RTS. We're going to start there, and then we're going to follow what the OEM says. And some of them are going to say to use mechanical fasteners, which we're going to talk about, some bolts or self-piercing rivets or whatever it is. But then in some cases, they're also going to want you to go with adhesive. Sean, sorry about that. And so we might have mechanical fasteners with adhesive, and then Larry, why would we use adhesives then? Why are they going to put adhesives in where there wasn't adhesives to begin with?
A lot of adhesives are used basically for corrosion protection and sealing. That's really the main purpose of it. If it comes from the factory already there, it probably has to do with both of those, and probably a little bit more with torsional strength or adding strength to the area. But if the panel didn't originally have it, and we have to do it in the aftermarket field, like Doug said the last time when he was here, when he was with Chrysler and now with Fuser, they were doing it basically for corrosion protection and sealing purposes. And that's a big issue. They don't want the cars corroding out and stuff like that. And almost any time you use a rivet, you're most likely, I can think maybe 10% of the time you're not using some sort of adhesive with rivets. You're going to see adhesive used, and there's going to be a variety of different adhesives you're going to have to use basically based on strength and what the manufacturer wants. Much like Doug said, you're probably going to start seeing companies now having weld sealing, where we can actually use a seam sealer that can be resistance welded through. I don't think you'll see rivet sealing because it's either rivets to rivets, like Mercedes-Benz has with their steel cars. But I could possibly see Benz saying, you know what, put a bead of some sort of seam sealer down, and then put the rivets on where the arms, resistance arms can't reach, and then put a seam seal over the top. That makes sense, it seals it out. But for the most part, aluminum to steel or aluminum to aluminum components, you're always going to have it. Now, the reason that a lot of the German companies or European companies are using adhesive, not only for corrosion protection and not only for sealing, is because a different type of corrosion, which is galvanic corrosion, which will occur between dissimilar metals that are going to be matted together. So you sometimes have an inner steel structure, like a lot of the Audis, with aluminum structure attached to it. So this adhesive
with a steel rivet.
With a steel rivet. Yeah. Well, the steel rivets are usually coated, especially coated with usually a Dackerman coating, which is a type of process that actually bakes this coating on at like 700-800 degrees. And then you squeeze everything together. So now you got this mismatch of different components.
Some mixed materials going
all
on.
together, and they're out in the elements. You're going to have moisture and other elements out there, which is going to create a petri dish. And they needed to prevent this from happening. So besides the top coats on the outside, we have this seam sealer, or in this case now adhesive, that's going to be in between. That's going to add some strength, going to add some predictability to the applied impact forces and how the vehicle reacts. And on top of that, prevents against cross-contamination.
And we also have the other issue, which a lot of people don't think about. They figure, well, we're doing a rivet, it's not a weld. But we also have to seam seal the edges so water doesn't get in between the seams if we're not using adhesive.
Correct.
So there's a whole other corrosion protection thing.
Yeah, because as you seal it, you can see you got the
water gets in there.
You're going to get water that's going to get in there. And even with seam sealing, and I haven't heard any manufacturer says you can't do this. I would just take a bead of seam sealer with some sort of little bit of thick glove and maybe a rubber pad or a rubber glove on top of some sort of thicker leather pad, and just rub seam sealer across up with a nice thin bead and just rub it and get it in that seam. After you're done priming or straight to metal type application, all you're doing is you're preventing you from having a corrosion issue later on. The factory doesn't have to do it because they dip the cars. So when you dip this, all the material gets in between these panels, and a lot of times they use also electric static to help assist in getting everything stuck in there the right way. And we've seen cars out of the factory that still get rusty. So we have to really prevent it for ourselves. We don't want a car back in 10 years. Like in Arkansas, you guys have cars that are 8 to 10 years old,
we have so much
which
salt.
is more of the country than like Houston, New York City, or parts
Florida,
of California, where people drive their cars for 3 years, give them back, and we don't see the cars anymore. But as soon as you leave a metropolitan city, people keep their cars 8 to 10 years.
Right, which is one of the things that we've learned. We talked about it. I'm not repairing the car for just now, and I'm not repairing a car just for this customer. I have to know that that car is going to stay on the road. 11 to 14 years is the average road life of a vehicle right now. And as the repairer to last touch it, I am liable not only to the owner that brought it to me, but to every person that owns that car after.
You're liable until they crush the car.
Yeah, exactly.
Providing that you don't get into a collision event that maybe totals out the vehicle, or it's a few years older and the vehicle's not worth fixing. Take a look at engines nowadays and transmissions. Oil changes have extended now. Oil filter, the problem with oils can go about 10,000, 12,000 miles. Problem is the filters don't. But they've advanced on the filters. Now the car tells you, based on your driving habits, how dirty the filter is and when you need an oil change. I'll be honest, I drive my car hard. I'm up at 7,000 miles right now, and it's at 25% before I have to take it in. You also have starters don't get changed anymore. Alternators don't get changed anymore. Spark plugs, 100,000 miles before you do a spark. So cars are made to go and last a lot of years. Problem is, we have cars that wind up making collisions with each other, and sometimes they're not fiscally feasible to fix. And that's the issue. So that's why you have to really make sure, if you do get a car in an accident, you got to make sure that corrosion protection is there, especially if you're not in a metropolitan city where you know it's not a lease. This person bought this car, they're keeping it for a very long time.
Yeah, exactly. So let's go through, we've talked about the type, right? It's either straight mechanical fastener or mechanical fastener with an adhesive. You're welcome, Sean. But then, what are the types of mechanical fasteners? What all are we going to see in the collision repair industry out there?
Well, you have a wide range of different type of rivets. Reliable has this nice little metal rivet type application here, display piece. for demonstrative issues. As you can see here, and it's got a wide range of different type of rivets, anywhere from self-piercers to a nutsert. This is just a really big version of a nutsert. Obviously, it's not used on most cars. It's got only certain applications, but you can see there's a ribbed area here. It's got a big collar washer on it, and then when this gets compressed, it's going to give you this look here where it collapses around and actually locks in there, kind of like a rivet, but you can still put a bolt in here, attach a mirror or something like that to the side of a door. We have self-piercing rivets, and I know this can be a little hard to see, but here's a self-piercing rivet, and it's got one head on the side that's flat, and then the other side's got an opening on it, and this goes through the outer piece only, completely, and only into the backside piece. So if you look on this front one here, there's two different versions of how the back of the head winds up collapsing and crushing in there. This is not the rivet itself, it's the shape of the rivet, and this back piece actually got pushed around it. And then you have your standard.
And those aren't self-piercing.
What?
These aren't
Those are
self-piercing.
flow forms.
Those are
Oh,
flow
flow
forms.
forms, I'm sorry.
Yep.
Flow forms there.
Self-piercing
Self-piercing is
there.
down here.
Yep.
I'm pointing to the wrong ones. Over here, you have a locking type collar here on this type of rivet. This is a manual type rivet that needs a lot of pressure to collapse. Now, there are structural rivets and like non-structural type rivets, so it's very important, usually color-coded.
Yeah.
So you know the difference in what pressure you might have to use for them. And then you have your standard rivets for a wide range of things. There are a few aluminum rivet applications, but most of them are steel-coated rivets that will protect and make sure that there is no galvanic corrosion, along with the assistance of the adhesive that's there.
Yep.
So looking on the chart, we got several things up there. We've got the self-piercing rivet and the flow form rivets that you talked about. Blind rivets,
Yep.
solid rivets. We saw the nut cert and the stud certs there. Bolts that are available, and
Here's
the
a
flow
stud cert.
drills.
Yeah, when we get to the bolts, it's going to be entertaining to
Yeah.
see. It's just not a pretty repair, but that's how they say to do it.
Yeah.
Right, and the
And
flow
then
drills.
flow drill screws, and we'll talk a little bit more about those. So there's, all types of mechanical ones, and then when we're looking at, I was talking to Mike yesterday, and we're talking about the self-piercing rivet versus the flow form rivet and the different strength characteristics on why they would use certain ones in certain places. And in a little bit, we're going to be talking about a car that most people have seen or even repaired, the F-150. And all the different applications of the different rivets and why.
You could put a door opening on or a uniside piece on.
Yeah.
You could have 3 or 4 different rivets.
Well, the
you're using.
F-150's got 6.
Yeah,
Yeah.
yeah,
So,
lots of
you know.
different ones, lots of different changes, lots of different things
So
to go
there's
through.
different
That's-
types, and you
none of
can't-
that's included.
Yeah. And you can't substitute, say, well, geez, I've got, I'm out of self-piercing rivets, so I'm going to throw some flow forms in, or I don't have any flow. I always say that 20 times fast.
Yeah.
So flow form rivets, forget it. I don't have those, so I'm going to use the self-piercing because there's different strength characteristics. So we've got to be really careful where we use these different ones.
I remember these abbreviations, you got to start to learn a little bit because you will see them in the repair information listed that way. It'll say like, 5.5 SPR.
Yeah.
It might say 6 SPR, which is the millimeter size head and, the
And
size
it's
rivet.
scary right now. I mean, just in the Cruise, right? A $19,000 car. How
Yep.
many rivets are in the Cruise? 3 different mechanical fastening techniques just on the quarter panel and tail lamp pocket alone. And then yet when you call dealerships, I've sold 100 quarter panels,
And
but
no rivets.
never sold a set of rivets before.
Oh, that's
Right.
easy because that goes back to people don't
Read.
read.
Right, they don't know what they're doing. But now,
We should do a show where you teach people how to read.
Oh yeah, picture me teaching people.
I just wanna do
I
a
speak
show-
Brooklynese and
I'm telling
profanity
you,
fluently.
it's going to happen. It's going to be PBS style. It's going to be Larry in a smoking jacket, ascot and a pipe, reading Toyota page 5. It's going to be.
Well, we can do the electric company for pronunciation of words. Like here, watch. You just, I'm going to say something, and then
I
you
am
say
not
after me.
wearing
You
blue
say
overalls and a
no,
red cap.
You do like we do this on the side. And you, just say "uck." I'll say the first part of it. You ready?
Uck.
No,
No.
I got to say it first.
Okay.
Oh, it's some
So there's a reason why we're in the middle. So I can keep these two separate. Because you see what
Like
happens.
the
when-
electric company works out
see-
good.
Hey, I'm just telling you, you want to have a good time? Come to one of our live
Yeah,
classes here in
exactly.
Arkansas. 'Cause
You know,
they-
remember?
Here's the cool thing.
So you say "uck," I'll say the first part.
Okay. So here's the cool thing. All the crew that's in here and everybody's watching, they are getting entertained right now because this is live.
Yeah, that's what we love about live TV. So bottom line is,
Yeah.
we're not we're not fixing the cars right. It's part of why you're going to see a lot of the OE programs over the next, already we've had 2, Honda's announced their alliance with CCC. General Motors has announced their alliance with Mitchell.
Yep.
And that's one of the things they're going to be tracking. It's not just are you pulling repair procedures or whatever. Are you ordering the correct parts that go with the
Right.
correct
And we're going
procedures?
to talk about the
Right.
part selection here in just a minute, which, you know, you're going to take that part of the show. It's pretty important to get the right stuff. Here's the slide. OEM fastener versus the aftermarket.
Wait, I just don't have like a clip lizard bin for fasteners?
Oh yeah, there's a drawer.
You do, but don't touch
Watch
them.
this. He says, now I totally respect what you just said, Mike. You know why? Because his company sells rivets. And what did you just say?
We do sell rivets.
Yeah.
But to do your job correctly, repair procedure sheet that will give you every exact rivet that you need and position of where it goes and a part number that goes with that.
Is that integrity?
Yeah.
I
And
love
when you
it.
order a part number and you have the invoice in your file, you talk about creating a bulletproof file.
Yep.
That's part of it.
Yep.
Did you follow repair procedures? Yes, I did. Here's my invoices. Here's my sheet that I used to put it in. And you can color code your sheet. We'll be talking about that in a slide on what rivets go where to keep track of it. So the materials that you have available, when you get a self-piercing rivet, you get a flow form rivet, you get a blind rivet, how do you know what the strength is in that rivet?
All I know about that rivet is if it's magnetic or not. I don't know the strength. I know the size and if it's steel. That's all I know.
So, and a couple of things here, because if you can see some of the different height differences in the flow form rivets, it's not just the diameter of it, it's also the length of it.
Okay.
If you put a rivet in that's too long, you're not going to get a good hold on it. This is a self-piercing rivet that was actually too long and it's not set correctly. This one is set correctly. How do you know which one to use? Well, how thick is the sheet stack? I still don't know which one to use. That's why my repair procedure sheet will give me the part number of the rivet, because in the Ford door opening where we had there's 6 different applications of rivets in there
Yep.
and different positions of where they go, that is the strength of the rivet, the material that is being used, what is designed for strength, and in a frame rail situation, any kind of crushability that needs to be involved in that, and the length of the rivet. Because if it's too long, it won't hold correctly, it won't set properly. If it's too short, it will not hold correctly at all.
And then if it's the wrong rivet, it may not hold at all. And so we're talking about, we've been talking about welds and holding the car together and next accident and all that. This is all
So
about
when we
that.
talk about, we've removed a little bit of the human idiocy in the fact that the issues that can happen with welders. I can still have some issues with riveting
Massive
properly
issues.
if I'm not choosing properly.
You could have the same size head and different lengths, and you need to keep them separate and understand. I mean, literally, these rivets could be right next to each other like this in a repair procedure, and this one could be a shorter rivet, this could be longer by 4 or 5 millimeters, because this goes through 3 layers where the reinforcement starts, and this is only 2 layers. So it's really important to plan out where your rivets are laying out, and also keeping your rivets separate from each other, even though you might have a box full of them. Once you take them out a handful, you got to make sure you have the right amount.
So here's a great example here. This is 7.5 millimeters of stack, which you're going to run into on the CT6 on an A-pillar with the reinforcement
Some
coming
shops
in with the
are
rocker.
gonna do CT6.
So a regular flow form rivet doesn't even go through the stack. So when we put one in, we want to have one that's long enough so that when it gets set, go ahead and move those panels apart. There's one rivet there holding that. Just try and slide them. That's an amazing amount of strength just with one rivet. But it's the right size rivet for the right application.
I'd probably need a vise and some sort of chisel to try and,
And
hit
you'd
these
have-
and really to make it move, and it would probably start doing some damage. I mean, so it's meant to hold very, very strong. You added 2 more rivets to here, forget about it.
You'll never end up moving it. But
Right.
that is
That's
part
very
of-
Brooklyn. Forget about it.
Forget about it.
Forget about it. I know a guy.
I know a guy.
Yeah.
Right, you
I know
already
a guy.
catch.
Yeah.
Yeah.
So, and just a note to estimators that are out there, and I know a lot of you are estimators. So, we've been saying before you write the estimate, you get all the information on how to repair the vehicle when you write the estimate. So that, if they say we need 12 of this type of rivet and 15 of this and this type of rivet, that's got to be on the estimate.
Yeah.
Right.
So we order that as a part with the part that we're actually
You
ordering,
need
like
to
the
start making
Unisite.
some either cheat sheets, or until you get used to it. I mean, Mercedes-Benz it gives you a listing of all the stuff you need.
Yeah.
It doesn't give you the quantity. You actually got to count the repair procedure picture.
Right.
Versus BMW gives you a nice little picture of all the parts you need, but then you got to go look up the part numbers
And buy
for
them.
someplace.
Yeah.
So if you start making this cheat sheet for yourself as you do each one, you start realizing what you need for each car. I mean, an S-Class Benz 222 to put a quarter panel or a Unisite on, you're probably looking at about $1,200 to $1,400 in adhesive, foams, rivets,
Yep.
and their bonding material.
And it's
Their
not
bonding
included
adhesive.
either.
That's not included,
Yeah.
right? So I mean, this is before you ever buy the panels themselves.
Yeah, so part of the teardown process, one, is ensuring that you're not only you're getting paid, right? That you're itemizing, you're getting what's not included, and you're getting it on the estimate. But now I've got to order it and get it in, so that all of that stuff's available for the technician when it comes time to lay it out and do what you're talking about. So one of the best processes I think I've ever seen was Kai Young, who took us through a quarter panel replacement procedure he was doing on a Tesla. And he has this ritual, and the team gets together, and it's more than one technician because you got to put it on, you have the adhesive, you got to get the Clecos and all that stuff in place. He lays it all out. They count everything in the bins. They mark everything. They have a test drill, almost like here's what's going to happen when it's a live repair, and then I mean, so it's amazing.
Because he slows down the repairs. That's what I tell everyone. You have to slow down the repairs to do them accurately, which in essence will have you run more efficiently and have even less cycle time.
You're just slowing down to hurry up.
Yeah.
It's really
But it
easy.
was on. But what was great is every rivet and everything that he was going to need for that quarter panel was already on the cart. I didn't have the technician on the day that the panel comes in, then wandering around the shop looking for all
Where's
the
the
things,
rivets?
the rivets that he was going to have. They knew he had
That
them.
never got put on the sheet
Or
in
what's
the
even
first
worse
place.
is they say, hey, Joe, you got one of those rivets that are in the top drawer of the guy's box.
Yeah.
Yeah.
No, you should have a box. I'll be honest with you. How Mid-Island and Exclusive Collision and some of my other clients that I deal with, how they have their rivets set up is by manufacturer in drawers. So you got all your Audis, all your Porsche, all your BMW, all your Benz. They're all in the
But to be
different
clear,
areas.
those are the OEM rivets in the drawers?
Yes.
Not an aftermarket company putting
No.
stuff in a drawer. Just
No,
want to
no,
be
no.
clear about that.
No one goes into that drawer except the tech himself. As he uses, you know, if he needs 30 rivets for a job, we don't have to order them. We have them already.
Yeah.
And then as he's doing that job, the tech already the parts manager already knows he's got to order them, but we don't have to wait for the repair. The tech has
always
all the
have them,
rivets
yeah.
already.
Yeah,
so there's not an issue with
Yeah, I
having
totally get
rivets.
it. It's like
so
what Mike said.
sometimes you buy them in bulk. You know, it depends on the manufacturer. Like Ford sells a very large bag full of their rivets for that. So you got to split them up across numerous trucks. Versus Benz will sell them even individually in many cases. And some of them are coated. If they're coated, leave them coated. Leave them in the plastic bag with that greasy coating, and then you clean it off before you put it in. If they're just like this, you can put them anywhere. And you keep them in a drawer, and you have the part number on there. So in case there's always a little bit of redundancy to keep it easy.
So I will say this: I've never met an aftermarket company that's come into the shop to sell something that didn't really believe in what they were selling.
Sure.
But that it doesn't help you when it comes time to actually fix the customer's car, and it doesn't help you when there's a problem down the road later. So if they
Well,
always says you
where's your
something,
documentation from the guys telling you, yeah, this
tested
this
it.
will work for you?
Yeah, we've tested
Where's
it.
your
We crash tested
documentation that
100
that's
cars.
exactly
Well, and then you
what
got the other
needed?
problem. Let's just say that you put a rivet in that's too short. Obviously, that's going to be an issue. How about you put a rivet in that's too long and it does this that we just talked about right here?
No.
Yeah,
now what do
yeah.
you got to do? Well, we got to
You
pull this back
gotta
out.
take it out, yeah.
And now we got to put another rivet back in, and we got hole expansion and all that. So
And
now
depending
we
on
could
the
be.
type of rivet, you might
buying
have to
a
put it
panel.
next to it. And have
It
a
might be an
hole.
SPR going in, and now we're going to do a flow form where it didn't require a flow form.
Well,
so that's a
and
problem.
Where do you get that information?
I got that.
Do you decide that yourself,
Well, that's
or
the
do
engineer. So
Engineer.
Well, a real
Exactly.
body man will figure it out.
absolutely, 30 years of
A
experience.
I'm not
real
going to
body-
order the rivets at all,
No,
Larry.
it's a
I've
real-
been welding
I don't
them on
need this
for 30
Express
years.
800. I can have a hammer and a dolly, and I can easily put one of these in.
It's a bucking block.
No.
A bucking block,
No,
yeah.
when I'm I just weld the thing on with my MIG welder, and then I go back with my pencil eraser and I make it look like.
Oh yeah, right. No, you
Oh,
put
just
body
put that-
filler on
yeah.
the
Oh,
yeah.
flanges.
Yeah.
Put
Yeah.
body filler on the flanges. Pull the eraser out of the pencil and use the back of the pencil like this.
Yeah.
And it actually makes a circle, so it looks like a resistance weld.
I
It's
never heard
fantastic.
of that.
Oh yeah, no, not at all. Yeah,
All right,
yeah,
so
not
let's-
in New York City or Long Island or New Jersey.
What type of substrates? So, what type of substrates are shops going to run into this type of repair on? Is it only aluminum?
You're gonna see it on generally steel, a variety of steels, anywhere from mild steel in very rare cases, high strength steel in some rare cases, but most of the time you'll be dealing with advanced high strength steel, boron alloy steel, martensite steel, aluminum. Usually two different grades of aluminum, either 5,000 or 6,000 series aluminum, depending on the company. Composites you will see, but composites rarely get rivets. They usually get bolted or they get bonded. Very rarely do you
But
see
you can have a
bolt
shoulder
bonding.
rivet.
You can have a shouldered
Yeah.
rivet, that's
Specialty
in there,
fastener.
that's holding
They
it so the
don't crush
panel
well.
floats a little bit.
Yeah.
Yeah, they kind of crack, they have a tendency. And most of the time you're going to see with a lot of the German cars, and this will trickle down to American cars because we already have the Cadillac CT6.
And the cruise.
Well, the cruise isn't so much mixed material in the structure, but the structure mixed material, you're going to get this aluminum steel. You have to use some sort of adhesive for galvanic corrosion, and most likely they're either going to be riveting it, or in some cases now we see without it, and we'll show that afterwards, you'll be bolting it.
Yep.
Much like this picture here is.
Weld it on from the factory, and we're going to bolt it on in the repair.
It bolts on the repair, and they're regular bolts.
Yeah.
But they're also bonded. You have bonding material in there, so that's another thing you got to realize it's going to happen. Yeah. This happens to be the TT, and this is the front rail. I mean the upper rail, and there's a sectioning piece to change the A pillar or hinge pillar. And the back portion of the upper rail without changing the strut tower. And you have rivets and you have bolts, aluminum to aluminum, with to some steel areas with bonding adhesive.
So in New York, do you guys have a problem when you take a frame rail that was welded in, and then we bolt it in? Do we ever find those cars up on blocks with the frame rail stolen?
No.
Unbolted? Okay, just checking.
No, we'll show you later. Well, Porsche has an idea for that, and we're going to show you that afterwards. That we're going to prevent that from happening.
All right, so let's talk about OEM build methods that just can be duplicated, right?
You have clinching. Clinching's basically, if I take the top picture there, let's have a piece of blue bubble gum and a piece of red bubble gum. And I just bit on both of them enough to make teeth marks in the top and the bottom. That's basically what a clinch is like. I didn't put some sort of foreign object in between the two pieces. I didn't weld it by fusion and melt it. I just squeezed it so hard together with a little formation, it actually locks together. We can't duplicate that. You'll see that a lot of times on hoods. Inner and outer portions of the hoods are squeezed together that way. You'll actually see it on some doors where there's no door skins available, and you take off the belt mold and you'll see these markings like somebody bit it with one tooth and just smashed through it, and that's just squeezing the metal together. We can't duplicate that. The other thing we're also seeing is a friction stir welding, which is basically, it looks like a pencil eraser, and it's being spun like this at a very high speed, or like a drill, and it's running along a line so fast that it's actually creating enough friction to create heat to actually melt these two pieces together, but it also has a cooling factor to it, so it's like a resistance weld in that way that it welds very quickly and cools off very quickly. This is in the manufacturing field. I mean, we could get one of these probably $4 or $5 million, but there's no procedure to do it anyway, even if I could get it.
Let me just rush right out and buy that.
Just similar to laser welds. Yeah. You know, you can't duplicate those either.
Laser, really?
Yeah.
Okay.
No, you can't. No, they'll sell a machine like that.
Yeah. Okay. Just checking. So one of the things that on a damage analysis is a lot of times on hoods they'll clinch the inner and the outer together, kind of in the corners. And even if you don't have damage on the hood, when you take a side sway bumper hit, sometimes you'll see that inner and outer will separate because it'll pull out of that clinch, and we can't.
A lot of the aluminum panels, you'll see that too, like the hood or roll. Listen, I've never been a big fan of repairing a lot of damage to hoods, but I've seen guys years ago with mild steel hoods where the inner and the outer bent, and you'd be able to bend it back in some cases. Aluminum doesn't move like that. They move it. You can't heat both panels at the same time, the inner and outer portions of aluminum, to have, and it always separates. So it's pretty much you just got to get rid of it. Most clinches, I'll be honest with you, anything that you see a clinch on, you're probably not repairing, you're replacing as a component. Like a lot of the German cars will have clinches up in the areas of the door. They don't make door skins for German cars. They don't make an outer skin for a hood. You know, and you're going to keep the inner structure, so you're not going to really see that a lot.
Although I've seen some people write replace door skin LKQ. What was that?
And you've also seen, if you look a lot of the hoods, like the Ford I think has it, if I remember correctly, where the hood the hood striker is attached to the hood itself. So you got the inner and the outer hood panel, and then there's a plate on the inside that holds the striker that's not movable at all. It's not adjustable. You'll see these round circular type things. Well, that's clinches on that. That's how they're attaching that striker plate to the inner portion.
So in a damage analysis, we want to be looking, and if those are pulled or separated, there is no repair, and that requires a hood now.
And that's got to really be a lot of significant applied impact force to actually make those move, because you got a lot of metal pressed together there. Unlike a resistance weld that you're welding two pieces together and you're actually thinning it out in that area, this is actually making it thicker because you have two pieces together. That are squeezed together. That's a very thick area. For one of those to pull out, you got a lot of applied force.
Well, bottom line, there's a lot of stuff in the build that we cannot duplicate. So the people that says I'm putting it back just like the factory did it, you've already kind of shown, I don't want to say you've shown your ignorance a little bit, but just that statement alone coming out of your mouth tells me that we got some work to do there. So Tools for removal and installation.
And installation,
So
yeah.
let's go through the tools that you're gonna see in the shop for doing these procedures, or you should be seeing it in the shop.
Well, I think that
The
you could elaborate on
first
this.
thing you need to see is the repair procedure sheet. How,
That's the first tool.
How does the manufacturer want you
Access
to
to
remove
procedures.
the rivet?
Check. Okay.
Yeah, so it can be done several different ways. They can be drilled out. They can take your little belt grinder, quarter-inch belt grinder, grind off the heads of them. Some of them require welding a stud on and extraction on it. So it really depends on the repair
Depends
procedure
on the car.
sheet.
So, some can be pressed out with.
Yeah, some
Does
can
it,
be.
you know, like, does it
configuration
matter?
as to-
I mean, it's just a rivet. I'm taking it out. Does it
Yes,
matter
it
how I
does.
take it out?
So I can't
matters.
just drill a hole and punch it?
No, it depends on the manufacturer, what they say.
Yeah.
Just like Mike said, you got to read it. Sometimes you're putting a rivet in, like that. They might tell you you can pull this out. If you pull it out correctly and just extract it out by welding a pin on here, the size of the hole you're going to leave when you rip this out, you're taking a drill bit and drilling it bigger anyway.
Yep.
But once you pull this steel coated rivet out, steel particles, if I drill it, I pull it out. Now I'm only drilling on aluminum. So aluminum particles in aluminum aren't going to make that much of a difference. And you'll still vacuum it or clean it up or whatever, but they don't want the steel particles, so they want you to pull it out, but the rivet that you're going to be putting in here is going to be bigger than this hole. So that's not a problem. Other times they will allow you to drill through it, but then you got this whole process of you got to really clean the inside to make sure you don't have these steel particles, and then they even tell you they want you to flood the area with cavity wax or anti-corrosion compound so that any little particles that are in there are coated with this stuff so they don't corrode or
Encapsulated.
cause issues. Other times you'll just press it out. I mean, you'll have a tool something similar to this. On the backside, you'll use different dies on here, and the machine will actually, that you can put it in with, will also press it out. Other times they'll tell you, you grind off the front portion of it and you'll punch out the back portion of it. So it's important to see
But
what they
removal
want you
is,
to do.
It's pretty important. So I mean,
Because it's the back piece that you're keeping on the car. That's the
when
biggest
we think
issue.
about steel components that we were traditionally welding on, it was kind of like as long as the tech gets it off, they get it off, right? You'd let your C-Tech or your B-Tech spend maybe
Just get out the
just
on
get it
with
up.
Yep.
Grinder,
Yep.
cutting disc, whatever, just get the panel off. But when it comes to mechanical fastening, removal is extremely important.
A lot more surgical.
You can do a lot of damage
A lot
if you don't
more
remove it.
surgical.
Yep.
Because of the repair that you're going to be doing on the backside of the panel. So
If you pull this out and then let's say that the hole that you need for your next rivet is 10 millimeters, just making that up, and you pull this out and don't do it right, and the hole itself now is a 12 millimeter hole, we've got a problem.
You're done.
You actually just destroyed the inner to the point where, what do? Do we put it next to it? Do we replace the whole inner?
You buy the
I mean,
customer a new car.
You got a new car. I mean, that is slow down to hurry up, as you were talking about
Yeah.
earlier. Just like we got to really do the research.
But the point here to make is that while this process is somewhat less technical, as we discussed in the very first slide out the bat, right? It's more repeatable, less training in a way. It is not less important,
Right.
and that there are some serious mistakes that can be
There's
made.
as
It's
much
not-
training,
Yeah.
it's just easier to
Yeah.
learn.
I wouldn't
or
say it's
grasp.
less technical.
Okay.
You're probably getting a little bit more technical because of the type of rivet and the procedure that you need to do on it. Because
It's also a cleaner job. It's a much cleaner job.
much cleaner job, yes. You have the cold function part of it where you're not introducing heat to anything. But the most important thing is OE to OE to OE will generally have different processes and ways of doing them.
For reasons.
Because our initial start was this many pieces in the beginning for a die kit. Now we're into multiple boxes of multiple types. This is a Mercedes-specific die kit. We have a GM die kit here.
I don't know which one you want to show here.
Yeah, we just have
Just
all
show 'em.
different ones. So what this requires, however a manufacturer engineers and builds their product, the easiest way to make a comparison is a Boeing airplane versus an Airbus airplane.
Right.
They're both airplanes, they both fly, but they're built 90% the same, and it's that last 10% of the materials that they use, the way that they attach things, the adhesives that they use, the processes that they go through. Same thing in cars.
I'm from Seattle, so I'm pretty partial to Boeing.
Yeah. So, Mike, is it pretty fair to say that, I mean, 5 years ago,
5 years
this
ago
would've
was
done
this.
about everything?
Was this.
yeah.
And now we have got to so many different types and grades. The flow forms have gone from just a 6 millimeter to a 6 millimeter, and now an 8 millimeter flow form, Mercedes specific, so that they can actually have a stronger rivet in more structure of the car
Right.
because for more riveting and bonding, even on the ultra high strength steels, it's not just aluminum.
Right.
Ultra high strength steels, the more that they develop them, the thinner that they become, the stronger that they are. Think about drilling out a spot weld on an outer panel that you're saving the reinforcement on the B-pillar, and as you're drilling that, the amount of heat that you can create with having the wrong drill bit or going too fast, and now you've actually overheated the situation and put a hairline crack in the boron reinforcement. So think about this, and we're going to talk about this in one of the slides, but think about some of the processes now coming where you can actually punch out an 8mm hole or a 10mm hole and take out the whole spot weld.
Yep.
That's a cold process
drill
right
bit.
there.
No drill bits.
No drill
No.
bits. So that's
Because you're replacing a spot weld with now, like you said before,
a rivet.
now a rivet versus the, some of the other stuff that we've seen. It's like, oh, wait a second, well, we're replacing a spot weld that we're drilling out on BMW with a rivet. Okay, fine. But now this is the new process that you're going to see. You're going to be punching out spot welds.
Yeah, let's keep in mind, we're going to talk,
punch a hole
we've talked
completely through.
Mercedes, we've talked BMW, but this is something that's General Motors and Ford and whatever. If you're a body shop in
coming
North
to the car
America,
maker near you.
I don't care if
It's
you're a
there.
dealership or not, I don't care if you're on some European certified program. If you are a body shop in North America, a one-man operation or a 50-man operation, you are going to be riveting.
Yeah.
Yes.
Yeah,
There's just no way around.
You're going to see more of this from GM because GM's following a lot what the Germans are doing. Ford has some different processes with theirs that they haven't, because of the way the truck's configured, they haven't needed all the German styling to it, so it's a little bit easier in some cases with theirs. Cadillac's following it very, very strongly because I believe Opel had something to do with it, or the Germans had something to do with the design of the CT6, and I'm sure they're going to trickle that down to other vehicles. So shops have to realize, I mean, yes, there's a bunch of different rivet guns out there. We'll talk about those. But the Express, as you can see, we got 1, 2, 3, 4, 5, like 5 or 6 different heads here, 6 or 7 or 8 different boxes that will adapt to this. And basically, this is like having a resistance welder with, 8 different heads to it and, tips. 8 different tips specific to the OEMs, and this will assist you in doing whatever you need. What's nice about this is you don't have to keep buying rivet guns when they do an advancement. All they do is they either have a pressure multiplier that they can develop eventually, or just tell you, oh, well, you have to add part B to the Mercedes-Benz kit because we have this new process. And they'll come up with another little set of dies that'll go inside the box, and so you'll have everything there. Your expenses up front big, and then once you have it, you just buy these little smaller kits.
Yeah, the OEs are getting serious about getting very serious about how we fix cars. They're getting very serious about making sure that we're fixing them correctly, and they are very serious about the happiness and lifelong brand engagement of their customers.
Absolutely.
So I'm super duper excited to see what General Motors is doing. The General Motors people have made there's no hidden agenda. They are very open and honest about we want cars fixed correctly and we want certified shops fixing cars, and we're going to do everything we can to make sure that happens. But for everybody else, hey, I'm just a one-man shop. I'm not fixing all the brand new late model 2018, 17 cars. You're still going to be riveting. Yep. So, so this definitely applies to you and something that you're going to have. So. Mike, walk us through.
All right, so a little bit about the rivet gun itself. Interesting setup of the couple different guns on the markets. This one is mainly a main, what we call a power pack. This is the main power source. This is the pump. We have pressure control, a speed control on this. Everything gets attached at this point.
And that one's pneumatic.
Yes, this is air with hydraulic.
Yep.
So it's just an air hose onto it.
Is there issues like, we see that there's some battery operated rivet guns on the market, there's hydraulic. You guys just told me like on a Ford I may have 50 rivets on one side and 6 different types.
Yep.
As a shop for work, I want to say workability, does it matter? Do I run out of battery? Do I end up,
Listen, the guns that are out there, they're functional. They do what they were designed to do. Remember, we started out with this amount about 5 years ago. Yeah. So now we go 5 years later, we're way beyond this. We're way beyond the original set of dies for doing self-piercings and a 6mm flow form. So originally, this is pretty much all you needed. A push head, a C-arm, a set of dies, you're good to go. As the OEs start changing their process, their procedures, the amount of material that you can go through, hole punching, This is a punched hole through a 7.5 millimeter stack of material that was done with this gun. That's part of the hole punching process. This is done super clean, super smooth. So as things start going on, they've added this piece, which is now a push head and a pull head. So it actually has power going out, power coming back to assist in the extraction process, in the hole punching process. We have blind rivet heads in a 2-ton, a 5-ton, and they've added an 8-ton. So you can see the difference in the sizes. This was necessary for part of the Tesla program and the GM program. So this is actually a blind rivet head that has different attachments that go onto the OE specific rivets, what they're looking for, and you have 8 tons of force pulling that piece out.
Right.
One of them is the extraction of some of the self-piercing rivets that are being done with that setup. Some are the pin and collars that Tesla uses on their program. So the cool thing about this gun is this does not become obsolete. This is the power pack. The amount of pressure coming out here will be multiplied by the size of the piece that is being made for it. So same amount of pressure coming out on a 2-ton piece, the size of the cylinder creates the 2 tons of pressure. Now we increase the size of the cylinder, same amount of pressure coming out, now we have 8 tons of pressure.
Right.
So the engineer who designed this is...
But if we just start, I mean, not from attachments. So, you know, Larry, your shop, does this a lot. If we just start with Power Pack, right? I'm a body shop. I'm thinking about making a purchase. I'm going to sit down and go through my repair matrix, right, by my OEs. And I'm going to have a couple of different guns come back to me as potentials, correct? So battery versus pneumatic, does it last longer? Does the technician able to complete the whole repair? Are there any advantages to the Power Pack?
You should always have 2 batteries if you have a battery operated, one charging, one being used. As long as you charge your batteries properly, you shouldn't have much of an issue with them. As far as the operation of the gun, each manufacturer is running through tons of tests. So you might have a company that requires this pneumatic gun, and they might also require a electric gun for something else.
For something else.
I don't know, for reach, power, whatever the case may be. So you have to pick what the manufacturer picks. You can't say pneumatic versus electric versus...
Keep in mind though, battery-powered gun is limited. It can do self-piercings, it can push them out.
Yes, it is limited.
It's not going to be setting flow-form rivets.
No.
Right,
Battery-powered ones can do some blind rivets, but when we start getting to some of the ultra-high-strength steels,
I'm going to have to go here.
this has 8 tons.
So if I'm a shop making a purchase decision right now and I'm thinking, we're on the anatomy of the rivet gun, and I'm thinking, what is my base? What am I going to start with? And I start looking across the OEs and I'm thinking, I've got General Motors and I've got Ford and I've got all these other in there. That's a consideration, right?
Yeah, well, you have to look at and see what OEs are you looking to do. Are you going to become certified with that OE? Then you have to get specifically what they say. You might have a choice of 2 different ones. You might only have 1 choice. If you're not sure what you're going to be doing, if you're not getting certified in anything, this is probably one of the most versatile guns because we pretty much have everything for everything.
So I've seen some of the guns where this is an 8-ton head here, but some of them actually have the head contained in the whole unit.
In the whole unit,
so,
yes.
you know, in this case, we got a 2, a 5, an 8. Some of them will be a 2, and that's what it
That's
is.
it.
If you want an 8,
that's part of some of the
Gotta look
original
at
guns.
The biggest thing is when, like he said before, 8 years ago, it was these 3 guns.
Yeah.
Okay, but this wasn't set and attached here. You have your, your release, and you lock it on. Who came up with the idea? The engineer came up with the idea of the release. Why do I have to release them when this is all I have? We have 1 manufacturer. No. The guy who engineered this, probably talking with some OEMs, probably trying to look towards the future, says, no, we're going to make this 1 unit, unlock it, put in different heads. You need something upgraded. We can upgrade it by, once again, changing the size of this piston or cylinder to make stronger stuff. And you can feel a huge weight difference. Feel that and that. You feel a huge weight difference between the 2 of them
because of the material.
as you put it on there. So now I have an adaptable gun. This is like buying a resistance welder, like the PR-10. When Ron was the first guy to come out with it, and now you're still using it because all you had to do is just change the head. The head gun, the rest of the machine stayed, which we know isn't the case because that works with electricity. It's a completely different thing. But this is a pneumatic gun that they can pressure multiply different things with. And to my knowledge, if I'm correct, I believe everybody who has a riveting process, I think only 2 companies don't have this on the listing out of everybody.
There's just a couple right now, and we're in testing with a lot, but here's some interesting things. So this is how the piece goes on. Pretty simple. It's set on, it'll swivel around. This is a blind rivet head. So if you need to get into a tight area, check that out, and you get into a tight area. So you can pivot this wherever you want to get into the operation that you're doing. That's available on all these different heads right here. So the engineer who did this, by far, German
Hopefully
engineer.
he's drinking margaritas on the beach.
I'm telling
He knew.
It was intellectual property of the company he was working for at the time.
He's a German engineer that understands this business really well. He was part of the developers for the water jet cutting process, 76,000 pounds of water pressure coming out. He understands fluid dynamics and how to make things. He's very up to date on anything new. If we get a new, when these first started really coming out, the little stud certs, we gave it to him. He made a piece for this so that we can set these with one pull on the trigger. And we can set these correctly with the depth of how it's being set on.
I mean, do you know the guy personally? Because I'd like to know if he's like from the, aeronautics field, where he went ahead and he built all this type of stuff already for an airplane company to build planes, and goes, I'll dumb it down a little bit for cars.
Yeah.
And I already had this idea, so it's really ingenious that all you got to do is just change your head. I keep one thing and I just keep changing ahead. Think about computers. We can't even do that with computers.
Yeah, exactly.
So let's
We got to change them every 3 years.
Right now while we're on this, so mainly, obviously, shops think about what you're buying when you're buying and make sure you're
Right.
buying something that's going to upgrade with you and grow with the future. We
Right.
got a question coming in. Has BMW approved any other riveting tools for SPR?
BMW still has the PNP90,
Yeah.
which is one of the original TKR guns.
They have the Express. Is the Express on the list? I believe so.
The Express, I don't know if the official.
I got to look it up, but I believe the Express is. I
But
think it is.
BMW still uses this. All they use out of this is the two self-piercing dies, the 3mm and the 5mm. They're not doing flow forms. They're doing blind rivets, and their blind rivets that they're doing is what the Taurus 4, the air-powered, which is also a German-made gun, that has about 4,000 pounds of pressure for setting your blind rivets. That's all BMW needs. This is self-piercing rivets, which is, they're all pretty much the same, the 3s and the 5s, except for Jag.
Right.
Jag went for just a little bit bigger. I think instead of a 5.5, they have a 6.
Yeah, it's a 6mm, which you guys had to come up with another head.
Yeah.
All right, so let's real quick while we were on that, because we were talking about what are the tool manufacturers that are available out there?
Well, the most popular guns out there right now from multiple OEMs that have a certified program. And to get back to that BMW question, you can go, if you're on their certified program, there's a tool listing area, and that's the most up-to-date information. Not in some article that was written a year ago because something might have been added to it. Or even a position statement, I'll be honest with you.
Yeah.
Okay? Because we know we're...
the one I printed off, put in my binder's not good anymore?
No. You want to print out fresh. So, I mean, you got the Advel gun, you got the TKR power booster that goes with this particular system, the Taurus 4 for blind rivets, the PNP 90, which has been started about the same time as the Express. Both of those guns were the two most popular at one time. And then, of course, you got the Express 800, which obviously covers multiple manufacturers.
Right, and the goal of this company is what I really like about them is that they're very aggressive at different OEs. So Cadillac, when they were developing the CT6, our company was in touch with them on product development. The engineer came over from Germany several times with them in their testing process. And Cadillac actually went through, they do use flow form rivets. They wanted a flow form rivet with a countersunk head so that they can use it in a glass area so there's no obstruction coming up. The engineer who designed this designed a countersunk flow form rivet for their program.
Nice.
And so they cater to what do you need, what are you looking for, because the engineer, again, who did this, understands what the requirements are in the aerospace industry, in the car industry, because basically right now we have the aerospace industry on 4 wheels.
Yeah.
So,
All right, so I'm going
And we
to...
always get the question, what do we buy?
Yeah,
What's your favorite gun?
Right.
It's like, no, it's what does the OEM
It's like asking
say?
me what's my favorite kid, right? I have an answer for that. But I'm just saying.
You do.
Well, I know my brother's my parents' favorite kid.
Well, let me throw this out there too, because that is a good question. What do I buy? I'm not going to become certified in anything. What do I get? I'm going to become certified in 3 different areas. What do I get?
Well, I think the key, Mike, it doesn't matter whether you don't have to be certified, but you still got to fix the car right.
Right, but
Yeah.
if the cool thing about our company is we have a guy that works for us that all he does is the OE programs. He's involved. He was very involved with the Cadillac program, the Tesla program. He knows who will accept what. So great phone call to our company. Talk to Mike Kirchhoff. He's the guy that you tell him what you want to do. He'll give you your best options, whether or not they come from us or not.
Yeah.
Because if you have to buy something specific for Audi that we don't have, you have to buy that thing through Snap-on
Yep.
and get it for Audi.
Yep.
That's just part of the program.
If you're just going to fix Chevy Cruzes, then more than likely, because of the adaptability of it and the eventuality that other cars are going to be looking for it, your probably best investment is this setup right here, right now. You know, because you only got the rivets down at the bottom on, on the rocker,
Right.
on the Cruze, and they have no restrictions on it. They just tell you the type of rivet.
But look at GM as a company. They have the CT6,
Which is
they're
this is
not
already
just
approved.
doing. They're not just doing
I'm
it.
not
To,
worried
no,
about
they're
that
just
CT6.
not doing it to one car.
I'm
Yeah,
worried about
that-
that truck
yeah.
that's coming out down the road.
Yeah,
What's going to
the
be on that
CT6
thing? So,
CT6 is the least of our problems.
Yeah.
There's not that many on the road.
but it's what that's the direction that they're moving
Absolutely.
into.
Oh, yeah.
That's their pilot car, and you're going to see it pop up on a lot
Yeah.
of different things.
so let's talk about cost here a little bit because I mean,
This is free, right?
yeah, free system.
Free system, you give them away to
Send
everybody.
us a blank check. It's free.
Dave
No.
fixing to.
Yeah,
If you send me
Dave's stabbing me in the
$20,000,
eye right now from New Jersey.
everything on this table, if you send me $20,000, I will get this to you the next day. Now, do I get a discount if I buy more of them, and we'll put some money in your pocket and the rest of Dave?
And back this week on Brooklyn Negotiation Tools 101.
yeah, we're not in Brooklyn right now.
Now, listen, like I was saying, we have discount prices on these things right now at the Homeboy Shopping Network.
So Mike, in general, ballpark figure.
In general, if you're doing the basic starting out,
We get here, this, and the head.
the head, you do the basic setup for doing self-piercing. You're probably right around $9,000 for
Okay.
the initial setup.
Dollars.
This is the main part of it. Then as you add on to different programs, you can go anywhere from another $2,000 to another $6,000.
What happens if I
on
wanted
top
the
of that.
Rolls Royce Ghost,
You're-
top of the line, everything?
I want everything.
Everything in here, you're probably about $16,000, $17,000.
So
for
you're not
everything.
talking
But
where.
the thing that's cool is that when another die kit or another kit comes out, I'm not back to buying another $9,000 head.
Correct.
Right.
Yeah,
Correct.
That's
What
kind
you
of
got
cool.
to think about is if you're going to build an aluminum shop, you're looking at probably about a $250,000 investment for the first portion of it without the building, and then just probably anywhere between $20,000 to $60,000 for each additional OEM. In this case, you're talking a steel shop, right? Basically, because this can be used on steel cars or mixed material cars. You're spending a cost of $12,000, $13,000, $15,000. A resistance welders range between $20,000 and $30,000.
It's like buying another welder.
So you
It
just
is.
have basically a cheaper welder that you're purchasing right now that's going to cover multiple vehicles right off the top.
Yeah.
Which is a nice idea. And you can see already, it came out 7-8 years ago. They've had adaptability to add more
Yes.
manufacturers on brand new cars. You can only suspect or assume safely that the next 2 or 3 years, this thing's still going to be relevant and adaptable.
We're going to see more of this. We're going to see less and less welding.
smart
and we know
investment in
it's
a way.
coming.
Right,
So,
and we talked about punching out spot welds. This already in the Mercedes kit is already set up for 6mm and 8mm punch outs. That punches do not get stuck in the material. The original setup with the PNP 90 with the self-piercing dies in a 6mm flow form for Mercedes at the time, there was a punch in there that when you punch out a 6mm hole, the punch would get jammed every time because it just draws material in with it. The engineer designed this now with a detachable cutting head that as soon as that thing punches through, it immediately pulls back. You go on to your next one.
nice. All right, so now that we've got sticker shock with everybody, let's talk about how we're going to pay for this thing. So, and we pay for the equipment in our shop through the processes and procedures that we do, and they speed us up, and then we get compensated for the things that we need to have. So let's talk about preparation.
Well, you have a few different things. I mean, obviously, once you punch or drill a hole or anything like that, you're going to have to deburr it. Drilling a hole will cause more backside material debris that you're going to have to clean off versus punching a hole. But everything's going to have to be deburred to a certain extent. Aluminum may have to be heat treated, and you're not changing the temperature, you're just wicking across it, which is that first kit, the Pyrosol kit that's for BMW, before you put their adhesive on. And there's a special type of activator and stuff you have to put on there. The next picture there, that's basically the Porsche procedure, where there's a silicone carbide paper that your company also happens to sell, because it's a very rare type of paper in this country, that has to be utilized on the flange, and you have to hand sand it. You can't use the machine. And then you spray this red spray on there, and you have to first break the bead with a rubber glove on, and then see if the red activator beads up. If it beads up, you have to keep sanding. If it doesn't bead up and flattens out nicely, now it's prepped. You use the cleaner, and then you can put your adhesive on. Ben's has a complete kit they sell with the silicone carbide paper, with the adhesive, with the activator, with the cleaner, with the whole 9 yards, and even the little Dopplers that you use to apply everything with. So they have one whole kit for it. Porsche sells everything separately, as does BMW. But you buy the Pyrosol kit with, you know, a refillable type liquid to have that little lighter go off.
My kits included?
No.
No.
No?
No.
The labor time to do all this deburring, special sanding, testing, sanding again, prepping included?
Is generally not included, and that's listed on a lot of the DEG, because I know I've sent in a bunch for BMW, Porsche, and Audi on their vehicles. No, it's been answered by the 3 database systems. No, that stuff isn't included. That's over and above. Best reserved for an on-the-spot evaluation. The normal cop-out. But I don't blame them, because you know what? It's a lot to do, and to actually sit there and judge the time and figure it out can be a difficult type procedure. So, and a range of things.
So as an estimator, I have now not only gone through and read my procedures, right? I have determined what it's going to take to get the panel off, which may require some additional
And
operations.
how many rivets?
I've determined my amount of rivets and placed them on my estimate and ordered them. And now, when I've clicked replace panel, I'm going to have a lot more line entries for my kits, my deburr time,
And that's
time.
why we've been saying, when you write that estimate, you got to have the instructions sitting right there. Oh man, I need this kit.
Right.
See, look, and that Mercedes kit. What is that? $400, something like that?
I think no, they actually lowered the price. I think it's a lot closer to $300. It used to be
Yeah.
$479. I think they lowered it down to like just under $300 or around
And
$300.
that's what you need, but you also need the rivets. So
And I
those are
need the
additional,
time.
and you need the time.
Yeah.
Yeah.
So there's a lot to do. So we've got a video, right? We've got a little video. Mike, if you're
just
doing
on
an SPR.
yeah.
Okay.
Let's go ahead and roll that.
We'll watch a little video of what this looks like when the shop does
All
it.
right, so what you see in the video is that the SPR is being put into the gun. The panel is going to be put in front of it. And basically the SPR is going to actually make the hole as it punches through. The piece that is going to be punched out is going to be pushed back inside the rivet to make it crush over on the inside without actually going through the second panel. You'll see there that I'm holding that up a little bit. That's part of my training video on that, and just discussing how the die assembly is going to collapse so that it sits flush. And then when it comes back, is going to show how the actual rivet looks.
Right.
So on that setup there, what I was showing on the die assembly, so these dies that actually hold the self-piercing rivets, there is a little magnet on there. This little piece on the top actually has a little separation in between it, and there's a big little O-ring in there that holds this up so that you can actually set the self-piercing rivet inside the die. And then when that crushes down, that O-ring collapses and it will allow that to come flush on the bottom, so that when you do a self-piercing rivet, your head on the top is flush across it. A little close up on that.
It's nice.
So, and on our website, we do have videos on all our stuff that we have. I do have about a 50-minute video on this gun. I go through it from start to finish. So this helps out anybody just getting the gun, actually learn the proper way of using it. And also after we've done training sessions, it's a great reference tool to go back.
All right.
You know, and it doesn't. And I would say I've watched the video. You know, and it's a great video, regardless of what gun you have.
It's good video.
It's a good video.
There wasn't a lot of action.
I know.
Or you know, restricted. Oh, that wasn't that type
Not
of
much
movie?
talking.
Not
no,
much talking. I
Stop
mean,
it.
you know, I don't understand what your inspiration for the role was in that.
Be the rivet.
Okay, so now we've got a video
There was
of
not
blind
even a car
rivets,
chase.
No.
which many of us were wishing we were blind right now.
No, we're going to do the flow form rivet.
So,
Okay, we can.
Car chase scene in this?
So what you're seeing on the flow form rivet is that instead of actually making the hole in it, we actually have to punch the hole in the panel first. And then as that goes through, it will crush the end over so that it actually becomes a structural rivet. So as soon as that gets done playing,
okay.
you took my sheet.
Yeah.
So
I'm just being your assistant.
This is the hole that
Here's a good
actually
panel.
gets punched for the flow form rivet. And the size hole, the reason why it's punched is because it makes it a completely round hole. If you drill it out, the drill bit will walk. You're going to have a little bit of too much side movement on it. This is an engineered hole so that when that fits in that, it actually has a little bit of play side to side so that when the rivet crushes this way, it pushes out laterally against the side of the panel and fills in what's inside there. And that's very important for the structure of the rivet.
And that's flow form.
That's a flow form.
Okay.
The difference between a self-piercing and a flow form is a self-piercing does not actually go through the panel through the second sheet. The flow form does. The flow form is a highly structural rivet. Self-piercing is structural up to a point. Whatever the engineer has determined that to be. On the new Audi Q7, on the upper wheelhouse, front wheelhouse, there's a lot of 5mm self-piercings. It is a structural part. When you're going through a frame rail section and a reinforcement, you'll be using flow form. So it's like the old the buildings with the big old rivet in that got crushed over on both sides. Once that's crushed, that's solid.
The Golden Gate Bridge, right?
It's not, yeah, it's not going anywhere.
Okay. And then now we've got blind rivet?
We got the blind rivet.
Okay.
It's a quick 4-second, just showing how the blind rivet goes in. Just pull the trigger, piece comes back, pops right out. So on the blind rivet heads, we have this one, the little 2-ton one in here, and then the 8-ton one. And all that is going to be in proportion to the size of the rivet that you're setting. Diameter-wise, on diameter of the mandrel, this will do the 3/16, this will do 1/4-inch rivets. Up to a point, it does have 2 tons of pressure. As you start getting into some of the more high-strength 1/4-inch ones, that's what the 5-ton unit is for. And then when you go into some of the higher ones, that's what the 8-ton unit is for. And again, this is all done trigger control, pressure control, speed control. So on all these settings, when you're crushing a rivet, you want to have control of your pressure and the speed of the way that the rivet crushes. As we get into more of the ultra high strength blind rivets, one of the reasons why they want this set now is a slower pullback on the mandrel so that when that ultra high strength comes bending back, it goes in the direction that they want it to. The flow form rivets, when they get crushed over, they actually get work hardened as they're being crushed, and they become a more of a high strength or ultra high strength depending on the flow form itself once they're set. So what you see here becomes something different when you set it here. So,
and thus back to get what the OE says.
Yes.
Order it, part number, strength, everything.
And specifics.
Yes.
So let's talk about what the OE says. So we've got kind of a little procedure clip here for what's going on with BMW. And I've got adhesive. It looks like I've got 2 different kinds of rivets on one panel.
That's just the adhesive is 2 different size
Containers.
cartridges.
Right.
Then you have blind rivets, which they're listed as N3 from them. There's 17 of them. There's punch rivets, which are self-pierces, which are 26. You have EMC screws, which are electromagnetic compatibility screws, which basically creates the ground again because of the adhesive being in there. And then you have your cleaner that you need for this. And it gives you a listing. And then another area of the website, like we did in the BMW program, they give you the part numbers, so it's easier for you
So
to
we order a quarter panel, we're writing an estimate for a quarter panel, that would need to be included in the
that's our
estimate.
shopping
in
list,
order.
yeah.
Right.
Yeah.
Exactly.
Right.
That doesn't include the foams that are in a
No.
different area of the repair procedure, you know, so that you'll have those listed wherever you might need them and stuff.
But that's one panel, 2 different kinds of rivet applications to put one panel on.
And that's a pretty simple panel.
Yeah, that's one of the more...
For you.
Well, now go ahead to the Ford one. Now you have the Ford one.
Right.
So now this is where you see.
This is where it gets a little more fun.
Yeah, so 7 different types of rivets at different locations. So all this means is what the engineer planned out on that. Some of those are double flanges, some are triple flanges, some catch a reinforcement. So for your setup on this, if you print out your sheet, take all your number 1s and highlight them with a red marker. Take your number 1 rivets and put them in the pile with a red mark next to it. Take number 2, use an orange marker. Keep on marking all the different pieces. Get yourself organized like Kai does. Everything is laid out. Everything is organized. Once you mix the glue and then you got it on there, you have a limited amount of time to set. You must set rivets while the glue is wet.
Unlike resistance welds, where most of them you can do it wet or dry.
Or dry, yeah.
You know.
And again, on this, refer to your repair procedure sheet, because they're going to tell you on that particular, on the F-150, what size hole specifically to drill.
Yep.
You have to stay.
No, it's 6.5 millimeter.
Yeah, you have 6.1, 6.5, 6.7, 4.3.
Now, all this,
you have all different
this time,
types.
right? So I mean, this is a Ford truck, right? I got 7 different types of rivets
Well, the top one has 3 different type of rivets. And that's probably a one-man job. The bottom one, if you had to replace that
The side panel.
door opening, that side panel, you probably need 2 techs.
Wait, is that included?
No.
That setup time where I'm marking rivets and putting them
No.
all out, laying them out, laying at my heads, is that included?
No.
The time that I'm switching and going back and forth on my machine and changing my rivet heads, is that included?
That would be, yeah.
Okay.
I mean, that portion of it would be. I mean, that's part of your tooling and stuff. You don't get paid to drop one hammer, pick up another hammer, you know, when you're doing hammer and dolly work or something like that. But yes, you would have to, you know, probably add some extra labor time to it because of the 2 techs. You have 7 different type. Well, really, there's 6 different type of rivets. You got the number 7 rivet that's down at the bottom there for whatever reason. But you have a bunch of different rivets. So one guy might take one whole side, another guy might take all. One guy might just do the 3s, and the other guy is going to do the smaller amount, like the 4s, the 5s. You know.
Now, Arkansas right now, we've already said we're inside today because it's 100 degrees out there with 100% humidity almost. Is that going to change my setup time on my adhesives? Am I going to have to be very cognizant of that?
That's why, once again, we go back to reading the instructions, like Mike said before, not only the OEM, but if they tell you to use Fuser or 3M, read the Fuser or 3M sheet that tells you what the humidity is.
What your time frame is.
And what your time frame is based on humidity and
So
heat.
it's realistic to think that me putting a side on this truck might look like a NASCAR pit stop.
Yeah.
I'll be honest with you, this might be something where if it's a very hot, humid day out, you might want to wait till later in the evening where it cools down to some extent to start working
So
on
what
the
you're
car.
saying is I used to come in and probably Matt, our tech's over here in the corner giggling when I say this, I used to come in at 4 in the morning and start painting because I would have to get good temperature to be able to get it. Am I going to start coming at 4 in the morning to put unisides on trucks?
Well, you may have to.
So we got a question coming in.
And then you got to get on. You can't just set it up there, throw a couple in to hold it. We got to get it riveted while it's wet.
Yeah.
So we got to be game on. So it's not like you put it up there and go to lunch and come back.
Well, and that's what Kai Young and his demonstration and his team did, is that it's a choreographed dance of who's going to be responsible for what, and I'm going to go here, and this is first, and this is second,
You know,
and I pull
Ford
these.
gives you a really good picture here. You could actually draw this out on the panel with an ink pen and make the areas for 3 all over the place. And you know where they are. And I'm just going to take I'm going to have 2 expresses. I'm going to use the gun to put it in, or the Henrob gun, the Henrob gun, the Pro Spot is their guns.
Yes.
So let's say he's going to use the Henrob for the Henrob rivets. I'm going to use the Pro Spot, and we're going to go ahead, and I'm going to do all the number 3s, and Mike's going to do all the other smaller numbers because he has to constantly change heads and stuff. But I want to do the big bulk of it by just boom, 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 boom.
Yeah.
So you got to really plan it out beforehand, like
And
a football team.
As the estimator, I'm going to plan that out because I got to figure out what's not included so I can add it to it. But yeah, it becomes a choreographed dance, and it may take a couple people. Now, so the question coming in is OEMs have a preference for their repairs, just like MIG was good for everything in the past. I'm going to disagree a little bit with that. I don't think that the OEMs always thought MIG was good for everything in the past. It was just kind of one
MIG
of those
welding,
things.
actually, because MIG is incorrect,
Yeah,
but okay.
so I think it was just one of those things where we had to have it. It was like a necessary evil in a way.
Well, there's
but
no way to
he's
do
just
it.
saying that
Yeah,
MIG was accepted
but
in the past
is
rivet bonding.
Well,
Is rivet
because
bonding gonna
MIG
be the
welding
normal-
was the only thing available. You didn't really have resistance welder until Ron came along to make one that was available for the aftermarket field.
Yep.
There were resistance welders like laser
Yeah,
welders
but
for the
here's
OEM
what
only.
here's what I want to be careful with, because I think when most people go, it was good for the past, their version of the past was 5 years ago, and it really wasn't.
No.
So,
Yeah.
but 20 years ago or whatever. But is rivet bonding or mechanical fastening going to be the future? Yes.
Yeah.
And they always have been saying this for 10 years.
Well, here,
now.
I'll
Here's
give you
where
an
we're going.
example. We just showed you the BMW quarter panel, right?
Yep.
And if I go to the front door opening, window post area and the A-pillar area, if I put that panel on, that gets welded. Wait, Larry, you're telling me I get a uniside panel like this picture. Here's the quarter panel, over behind Mark would be the A-pillar. On the same panel, same thickness.
Riveting there, welding here.
Riveting here, welding there, yes.
Yep.
That's why it's important to realize what and if you want the answer to that question, go to one of Walter Mallett's classes if you're certified, and he'll explain the whole thing to you. I'm not explaining it to you. And it makes sense once it's explained to you. But that's why you have to follow what the manufacturer says. Yep. So you might have an area where, yes, you might still be using mag welding, or squeeze type resistant spot welding, or silicone bronze welding, or a combination of it, and then another portion of the same exact panel in a different area, you're actually going to have to use rivets and glue.
Right.
Or adhesives, I should say.
But for the question, is it going to be the norm in the future? Yes, it's cleaner.
Yeah.
Like
It'll be
we said,
a lot more of it.
It's
it'll be
more
normal.
repeatable.
I don't know if everyone will go that route, but yes, it'll be more normal.
So what can go wrong? I mean,
a lot.
Right? We already know the OEs are going to it because it's a little less human error, right? It's a little bit more repeatable.
Yeah, a lot
it's
of stuff can go wrong. If you don't read the sheet correctly, or if you just assume you're going to use this drill bit and do that, like we just showed in this panel before, which is in that picture.
My foul belt sander takes care of everything.
Yeah.
It's a little bit too long of a rivet. You can have the wrong size, the wrong drill bit. You can drill out for what you should be punching out. The type of rivet that you're putting in, the wrong die set, the size of the rivet.
Well, what about, and the other thing that we were talking about yesterday was that if we have a 6.5 millimeter drill bit, how many holes do you get to drill with that before it's not actually drilling 6.5 millimeters anymore? You know, and so we have to really be cognizant of how everything fits, because otherwise we're going to wind up possibly making bigger or smaller holes than what we need.
This becomes part of, we talked about the technical part of this. Like, okay, this is easier to learn than aluminum MIG welding, but like anything else, if you don't understand the process, how can you do it? Because aluminum MIG welding, if you don't understand how that works, how can you even begin to learn how to do it?
There are some mistakes that can be made with this, but we talked about it earlier, and now it's that time in the show where it's time to get there. Bolts. I'm bolting parts on? What's up with this?
This is an actual repair procedure. These are my pictures from when I went to Audi school for the Q7. And this is probably going to be the repair procedure you'll see on most of the Audi aluminum steel hybrid construction mixed material vehicles. That should be out mostly by 2022. Basically, almost all of them will be that way, unless you're talking the A8 or the R8 or the TT, which is primarily a lot of aluminum. This new Q7 is heavily influenced with aluminum. It can only restricted parts, has to go to a mixed material shop. Structure, there's no structural welding. There's only non-structural welding on outer panels. So they're only doing a 1 millimeter to 1 millimeter with a 1 millimeter backing weld, versus we have to do thicker welds.
Right.
Like
so
on
this
the
is,
rails.
where am I going to see bolts? So OEM
well,
specific.
Well, this is the front, on the right-handed picture, that front portion is a cast. The rest of the rail is extruded aluminum, and it's welded together. If that front piece just breaks in a collision event, or you have a collapse at that crush initiator, that indentation there, you don't have to change the whole rail or even take the whole engine out of the car. You can section this piece on. There's a hole at the top, holes on the side. You measure forward from there, and you actually scribe a line all the way around with a speed square or with a sliding square, and you line it up. This new piece, as you can see, there's welds around these slots, and there's actually two inner sleeves that are already built onto this part from the factory. You put it together, you actually shave the edge until it fits perfectly. You put your jig in the front of it, or measure the front of it. If you have the car liner, if you have a Celette, you would actually put the jig back in there, make sure everything fits together, check everything out, and then you would drill your holes to put these screws in, these bolts, I should say, excuse me, and they have to be torqued in a certain fashion and to a certain torque spec, and you would put the adhesive on there, the Audi adhesive, which I believe is 3M, and you put it on the whole entire inside of the area. It squeezes all out all over the place, and you would bolt everything down. That's another important thing to realize when you do, and a lot of these are mocked up or don't have the adhesive in there already.
Right.
When you're using these tools and these dies, or the presses, or even the drill bits in some cases, you have to have like a can of cleaner and a rag or like an acid brush to clean these off very rapidly, because these can get very expensive.
Yes.
And as we saw before, there's a lot of crevices in here. You can get glue in here. Clean it out right away, not an issue.
Yeah, and on
Let
this
it
they
cure.
recommend acetone on this.
Yeah, acetone. So
Yeah.
you don't want to have that. So you dip it in the acetone, wipe it off real quick.
Yep.
Every so often, because you're gonna get squeeze out.
Right.
When you're done, you could always sand it off the car. You can't sand it off of this.
Yeah, you will
so
not get it out.
you clean this first, clean your equipment first, then you can go and clean
So
it off
this
the
isn't
car,
really
which
an-
is also what?
Not included.
Well, that's not a very
But
good looking repair.
It's
though.
ugly.
Yeah.
I mean, that's ugly.
Yeah, but nobody cares what you think.
Right.
It's safe.
Right.
Right.
Or, you know what? If you don't like an ugly repair, we'll put the whole rail in, which might total your car out. This is preventing a total loss in many cases.
But I'm a craftsman, Larry. I've been doing this for 30 years.
And aluminum airplane builders will laugh at you and think you're a clown.
Yeah. So this is just it doesn't look the same. It doesn't even look close to
Doesn't
the
have to.
same.
It's almost
this
the
is
same
right.
repair
Yeah.
as BMW had on the old Graf system. For what the E53, 63, where you would chop off the front portion of the rail and
Glue it on.
and glue it on,
Yeah.
It was not pretty.
and it was not pretty. And they said just leave the glue like that.
Yeah.
And
But it's
part-
right. It
and
is the
well,
right
and
repair.
Part of their reason was that they, for a car being on a lease turn back, and they knew it was in an accident, they can look at it and they go, that was repaired 100% right.
Right.
And that's why they didn't want you doing a cosmetic.
Right. It was
Right.
supposed to look ugly.
Yeah.
Yeah.
Well, we've heard, iCar made a really great video on flow drill screws that I think Jason Barton was in. Let's talk a little bit about flow drill screws. We've covered rivets pretty good. What are those? When they're popping up now more, I see
Well,
them
you're
more
going
and
to see
more.
a lot of them. There's a couple of different heads to them. Most of the time, they have this funny-looking 5 or 6 pointed-looking head. Some look like Tampa-proof screws, like a regular flat screwdriver. It's got 2 little portions. So you can have a couple of different setups for them. They're different sizes, different lengths. Some companies allow you to reuse them. Most companies want you to change them once you pull them out.
And just
But for
a
trial
note on
fitting-
that lower right picture, that's the F-150.
Yes.
That's the same car we were just looking at.
Right. That has
So
a
you
flow
take
drill.
the screw out, and we're going to put a blind rivet to put it back in, and they're saying, you take it out, you throw it in the garbage.
In
Right.
the trash, yeah.
Most of the time, if you have bolts, some sort of bolt, mechanical bolt, you'll use those to trial fit your parts. But when you're ready to put it in for good, you put the new bolt with the adhesive and stuff. When you're trial fitting, you can use the old bolts again just for trial fitting, but you don't want those bolts staying in there. The top photo, funny enough, and now you got to realize when these flow drills go in, it's got like a little self tapper at the end, and it concaves the bottom piece. You have a hole in the outside piece, and it screws together, and the adhesive is in there and locks in and spreads all over the place, like a Loctite. Even though you don't have Loctite on there, spreads all over the place, locks it in. You usually have to use a torque spec to it, so you don't over tighten it. The top photo is the left lower rear rail on a 991 car, which is the Porsche aluminum 911. And it's funny, they're Tampa-proof Torques. So I guess if somebody
Nobody can
works down
steal
the
it.
street, they're going to try and steal it, so they put in airbag bolts, Tampa-proof Torques, so you don't have a problem. But you can see the amount of bolts that are in there for this repair. Actually, this was a race car that Carmine's doing at Mid-Island Collision. The race team, when they buy these cars brand new, chop the rails out immediately, front and rear and strut towers, and we put in replacement ones because in the track it's faster to replace one that's been already done versus doing one from the factory because it's different type rivets they use.
All right. You guys talked about it a little bit earlier, but we do have some corrosion considerations.
Yep.
So
Whether it's steel or it's aluminum, if water gets to the site and around these rivets, we can have a problem. So we've got to do proper corrosion protection with the adhesives, seam sealers.
Trucks
it's
are
like we've
usually a
always-
little bit different because you usually only have wood and aluminum to aluminum.
Yep.
And that's why trucks don't get rot on their trailers, except down at the bottom where you do see there's some steel, you'll see rot down there, but the whole upper portion of it looks brand new, the bottom can be all rotted. So down there, they have to spray material in there because they really don't use that much adhesive. On the upper portions of it, it's just aluminum through wood to aluminum. So
Yeah.
there's not a problem there. We have a problem where we do have steel mixed in there, so we have to have some sort of protection there. It's almost like years ago when we had the Saturns. Saturn, the first 2 years, they didn't have it. All the rest of the Saturns had this little plastic tab that went over the bumper reinforcement where the bolts went in when it rubbed up against the rail. Even though it was bolted tightly, there's still friction in between the panels and it would cause galvanic corrosion.
Yep.
And they put this stupid piece of plastic on all those.
all right, so we've hit on it a little bit, but obviously I got to buy tools, I got to have trained technicians, and all that comes with a cost. And the only thing that brings money into a body shop, well, that's the estimating.
Absolutely.
And so that's the only thing. There's a lot of things that take money out the back door of a shop. There's only one thing that brings money into the front door, and that's my estimating. So let's quickly cover the not included list.
Well, pretty simple. Obviously, the adhesives, rivets, all the consumables, things you have to buy, daubers and all that stuff is not included because there's nothing included in the labor for
Right.
the consumables. Now, it depends on the database, and when we're doing the research, depending on which database we're looking at, whether it's CCC, Autotex, or Mitchell, it might include the adhesive install and it might not. And I'm not going to tell you which ones were which.
Yep.
I'm just saying, you got to look at that. And then prep for the adhesive, deburr the panels that have holes. Now think about it. You can't just go automatic deburr on everything, because what if you're putting a panel on that it's an SPR, self-piercing rivet, that you're not potentially going to have to deburr like you would in a.
Right.
So you got to know the repair going in. Of course, corrosion protection not included, seam sealer depends on the database, and many other things. So we just got to really read the P pages for the estimating database we're
and
using.
the multiple additional trial fits.
Yeah.
I mean, if you're going to put on a rocker panel, a lower portion of the A pillar and into the rocker panel, lower portion quarter on a Mercedes-Benz S-Class, you're looking at around 170 rivets, 170 holes, many of which have to be countersunk. So you have to put Clecos in every other hole, so you have to have a whole box of Clecos. You have to trial fit that on, drill the holes, make sure the doors fit, everything fits right, take the doors off, take the panel off, deburr the back of the panel, try it on again, make sure everything fits right, take it back off again, sand both panel edges, prepping them. Then you're going to have to apply your adhesive to your panels, spread it out properly, put it up, put Clecos in every other hole, and then start putting your rivets in. But as you pull out the Clecos, you have to clean the Clecos before you...
Can you put this in writing? This is a lot.
It's a lot. Well, this is what happens when you go to a Mercedes-Benz training.
Yeah.
You start realizing this. You can't just weld that on.
Right.
And you know, so this is some of the stuff that why our estimating series we're eventually coming out with will actually cover a lot of this stuff for people who are actually doing these type of repairs.
Yeah, because like we always say, you can choose what not to charge for, but you can't choose what not to do.
Yep.
Right.
So in my book, if I'm doing it, I want to get paid for it.
And you
So-
should list
Makes
it on
sense.
your estimate as you want to put a line 63 included non-chargeable
Right.
repairs, and then put a note and list all the crap you did for free.
Right,
But
because
list it.
that is part, and we talk about it when we talk about the bulletproof file. That is
yep.
part of it. That estimate needs to stand alone, and you never want to be standing in a court in a deposition situation going, "But did you do it? How do I know you did it?"
Not written, it wasn't done.
Right, you did. There's no blueprint.
Well, I did it for
or
But
free. I didn't
also,
charge
don't
you,
write
but
it and
you
not
still
do it
have
either.
And
So
there you
there's-
go. Those
we
are
got
two
both,
different
right?
things. So I think we've covered future directions during the show. Bottom line, more OEs are going to it. We're going to see more of this. I don't care if you're a one-man operation, a dealership group, or a large MSO, you are going to be riveting and doing some sort of mechanical fastening. So figure out what equipment you need. Make the best purchase decision that works for your shop and the repairs and the OEs and the brands that you're working with. Even if
Yep.
you're not OE certified, you still have to do the OE repair procedure, and part of that is the tooling.
Yep.
So I just can't say any old thing will do. I'll just go grab it.
Mercedes-Benz, Audi. Well, Mercedes-Benz and Audi have a one-day course on fastening. One-day course. And literally, it doesn't even
He's
fill
got
up
a
the whole day.
1-hour video.
It doesn't even fill up the whole day.
Yeah.
Porsche and other companies incorporated into their repair program for each one of their individual vehicles. If I was an OEM that was moving along these lines, I'd start looking towards, let's stay away from aluminum welding because we know the masses are incapable of learning. There's probably only about 240 technicians in the entire country who can weld aluminum who are certified for it, okay, through ISO with the German companies, or European, I should say. Maybe riveting's the way to go. And riveting, you make them go to a one-day course on the repair procedures.
They're already there. I mean, we talk about this for the Germans
This is
all
not
the
the
time.
future.
This,
But
I mean,
this
this,
is
That's
here.
the Germans.
this is for
but
I mean, we always talk about the Germans, and we make people think that this is German technology and it's eventually going to get here. It's here. It got here 5 years ago.
Yeah, an
I mean, between
F-150.
my
Yeah.
F-150s and my cruises and
but
everything
they,
is here.
The OEMs that don't have real hands-on training programs, just want to do everything by video, might want to think about moving this route of a one-day training course on riveting, include more riveting procedures, and they can keep more accountability with it because it's a lot easier to go over than welding.
The problem is, as I get this expanded to the masses, you know, you look at a General Motors, they can't do a one-day class. I can't have every shop that's going to fix a General Motors vehicle go somewhere and take a one-day hands-on training. I'm going to have to rely on my equipment suppliers and some other people to kind of help deliver that.
Then do that and have a one-day training course at the shop that way. But something has to be done differently than what it is. We've already seen some nightmare photographs of vehicles cut in 4 billion pieces that went through some sort of certified training. And it's a nightmare. You know, so we need to make accountability easier. This will make things easier for accountability because it's an easier process to learn.
Just to be clear though, that this isn't something that's just for certified shops. This isn't something that gets paid for just to certified shops. Certification and proper repair are two separate animals. While both of you should be doing the right thing. So whether I'm a certified shop or I'm not a certified shop, both people should be fixing a car exactly the same way, and that's the way the OE says to fix it. So one way to fix a car, pretty clear. Mike, thank you so much for joining us. We appreciate your expertise here.
Thank you.
No problem.
And bringing the equipment in. I think Larry introduced me to the Express 800 like 5 years ago at SEMA. It was his pick for rivet guns.
Actually, we went to Dave's booth and I went over it with you.
I mean, there's 1,000 different things on the market.
Cool Tools, it was a cool tool.
And there's 1,000 people coming in right now that always have a solution that tell you it's just as good, but bottom line, just go look at what the OEs approve and find something that fits you there.
And our company is here for the shops. I mean, Reliable's been going since 1987. Same person running it. His goal is to get cool tools out that work.
Well, I can tell you, Dave's never not answered my question. Sometimes I haven't liked the answer I've gotten, but Dave has never not answered my question, so that's
But there is a 50-minute video on our website, which is raeservice.com. Hopefully there'll be some info on the screen there. Number you can call the office, talk to Mike Kirchhoff if you have any questions about any of the OE programs, what's required, dollar amounts, give you a good idea. If you're just starting into this, it's a great informational source. And do your homework. Check on what you need. Other shops that are on that program, find out what they need. Sometimes it's very confusing.
Never listen to the salesman. I like the salesman. I mean, I do like them, but they're going to come in and
tell the salesman, don't listen to the salesman.
I know. But I'm going to come in and tell you that my tool's the one you got to have, and as a shop, I've got to do something.
And it's tough. You got to do your homework. Because you will find out later on as you go to get your certification, and they'll go, no, you have to get this.
Nothing worse than buying a bunch of equipment and finding out it's useless for the other two programs you're on, so sell it.
Now you got to buy something else. So, and we get Larry and I say this all the time. Don't ask us what we like. Ask us what you're fixing.
Ask what you need,
so then we'll know from there. All right, so we're going to be back next month with Repair University Live back inside because it will be July. And we have a surprise topic, depending on what's coming through. So I'm not announcing it right now. So stay tuned. When you get the email,
exciting, though.
When you get the email in your inbox, if you have registered.
Cool.
If you're watching this on Facebook Live or anywhere else, and you're not a registered attendee, it is free. All you have to do is go to collisionhub.com. Click over on Repair University Tickets 2018 in the store. You'll sign up. Your shopping cart will be 0. And what that does is get you on our distribution list so that you know what shows are coming up, time changes. We did have that one time change. We had to move it an hour ahead last month. So, but no more heat delays because we'll be in here. If you do want to donate to our air conditioning fund, do not email Larry at all. Ever. It's a good rule of thumb for everything. Email, start here, and then we'll be happy to take your donations, put a little plaque on the wall, right? So
now remember, for $40,000, if you act now, I will send you 2 of these.
It's going to be awesome. So we appreciate it. Thanks for joining us. We will see you next week with OE Live, and then we'll see you next month right back here for Repair University Live.